The thing has been hit. Hey guys, what's going on? Welcome to episode 2 of the slightly delayed Cosmic Council. I'm again joined by my panelists, Kali Fisher. Say hi to the folks, Kali.
Hello, people.
As well as I am joined by my other panelist, Jen Sharp. Say hi to the folks, Jen.
There we go.
Hi, everyone.
Alrighty. So I realized there's been a delay. I did some migration and stuff like that for this fall, but we're gonna reach out to some other. Oh my, no, I did send the other person on the other
Yes.
social media the thing,
Hey,
but
Rick.
oh, that's right. I should probably greet the chat. Yes, that's why everybody left. But
I can do this. I got
welcome.
my phone like totally set up here.
Okay, all right. Kali is on top of that chat. We got that. Welcome to our friends, Hexagon. Yes, buckle your seatbelts as they are hailing from Tampa, Gator Country. Rick is an interesting gentleman. But good to see you, my friend. I hope you and your family are doing well. Hexagon is greeting us, folks. All right, so where did we leave off? I totally forget. But we were talking about something, no true, isolate. All black holes be spinning. Is that more or less what we think we're
Yeah,
gonna
you
find?
and I were just talking about that sort of like that the physical stuff, but about black holes because Jonathan Agard just posted a few things that he's been doing on the web on sort of modeling according to using the Wolfram thing, and that he was making black holes and they were all spinning, and I don't know if he was intentioning that or that's just they evolved to spin. I mean, come on, who doesn't expect everything to be spinning?
I tend to believe that as well, and I believe Jonathan's work. Oh, hey, Mark, thank you for joining, my friend.
Boom,
Yes.
right there.
So, here we go. So, according to Jonathan on Twitter, attempting to reproduce the results of this archive papers, jet formation in 3D GRHM HD from plasma accretion onto spinning black holes using gravitas. Some progress in modeling the Blankford Zedek mechanism for increasing values of the magnetic flux. And we have these pretty pictures here. Yes, they all seem to be spinning. I can't.
A entity, Mark and Rick. Yeah, those are pretty sweet, huh?
It's well, this is where because he had done a rough thing like this about a year or two ago, and I remember the first time. I think I even told Professor Wolfram this as well. It's like when I saw that young man modeling black holes, I'm like, this young man is a wizard, and I continue to meme the Harry Potter thing just because I'm like, it just happens to be British. They both happen to be. The glasses and stuff. I'm like, all right, Harry, Dumbledore. I don't know. I love those movies, and the music kind of seems to fit. But no, it's basically the whole thing of this is you're taking the data, you're using hypergraphs to essentially map the most probabilistic ways and just try to follow the data as best you can. This is just my naive, like, not really understanding everything that's going on. I know Jonathan had done a couple of live streams with the professor, um, and basically, kind of behind the scenes, he had been developing some code, and it's basically, I believe it's supposed to be pretty good for the Schwarzschild, the non-rotating black holes. But as we can see for what he's actually done here, it is a little bit more complex. But apparently, it gives a pretty good first level approximation to what seems to be going on in this case with the magnetic fields. So kind of looks like a dragon going around. And again, I am biased. What do you ladies think?
I just think about, like, am I coming through okay?
Mm-hmm.
I feel like, okay, let's say hypothetically we do get that, like, mathematical description, a complete mathematical description of the universe. It doesn't seem to me like that necessarily implies the universe is therefore mathematical.
I mean, I'm not going to disagree with that. I think math is a language that can be used to communicate. Is it the only language? No.
Yeah, it's more like I
Well,
think.
the idea is that it would be that
Welcome.
represented physics. Sorry, Kaylee.
No, it's just, yeah. I think Jonathan had
And
sort of
before
like.
you go on, sorry, I think you're having a bit of an audio problem. I don't know if you can put headphones on, but there's
Oh,
a slight lower quality to your audio, Kaylee. You're okay, means.
I did take my mic out, so it wasn't
okay.
resting nicely.
I'm hearing it now. Okay, sorry.
It's just that unfortunately, I can't always grasp onto exactly what you're saying because there's like this compressional trilling at the end and beginning of what you say sometimes. So it's just like truncating
Okay.
the very last or the very
Is this
first
better?
thing you say. Just talk for a bit and we'll see.
Is this better audio? Do we have better audio? Not better audio?
I think there might still be a little bit of
Oh
truncation.
shoot! Now I can't hear though. Wait, let me turn it up over here.
Welcome to the live internet, everybody. That's all right. It's all right. But as Kali's finishing that out, see, this is why it pays to actually have like a wave analyst on, because then you can actually identify what's going on. Oh,
Yeah.
okay.
So, how's
Now I can hear
this?
the stream audio.
There we go.
Yes, there we go.
I had to switch. My mic. I only have I don't have a splitter for the headphone mic thing. So once I lose one, I lose both, or use one, I use both.
Let me
I
test.
think we'll
test
be
1, 2.
okay as long as you just like maybe talk a little slowly. I think we should be okay because I can mostly understand you.
Yes. So Jonathan had mentioned in one of his recent casts on that. I don't know, some guy with short white hair, brown hair, who does interviews with Jonathan on YouTube. But
The Lost
Jonathan was
Theory.
basically like saying, yeah, let's just give up on the whole. Can we just let go of this continuous, non-continuous debate? Because if we stick on it, then we'll never get anywhere, and we'll just accept the fact that, yes, as soon as there's any discreteness, then there's a false grain that we're imposing on things at some point, and we just live with it and go, well, this is our best approx.
I mean, you're not
You
going to
know?
hear me really just post outrage against that take there. I mean, I'm also biased. I also tend to.
Well,
I tend to.
you should, memes, because there's an obvious counter argument to this. Not that it's not a good argument, but you said discreteness imposes a false grain. The periodic table is discrete, and the grain it imposes isn't false.
No, but how do we know where that grain is?
It's not anywhere because the periodic table's not anywhere, but it nevertheless confers a limitation upon the precision of simultaneous measurements.
But it's,
based. Go on.
we just said it was discrete, yes?
Right, but it's a non-local discreteness.
She's saying it's based upon my knowledge. It's something that we have modeled. It's a very pretty thing. It can be displayed in a number of different, very interesting ways. But if the claim is, if we have that as a model for the building blocks, perhaps we could use as a guide to help model other things.
Well,
Maybe.
I mean, the shape of it, et cetera, is a model. But I think the sort of the and it's not the best model. Really, there should be sort of be like the line. There should be a diagonal line of most stable isotope of all the elements, and then from that line of the most stable ones, we can veer off in directions on all the isotopes with a sort of bell curve on the sides, probably, that slopes down around according to decay rates. Like that would be a most informative and respectful, I think, way of really understanding the full scope of what's going on with all this nucleons and stuff.
Well, I can see how you would think that, but variability in the neutron number doesn't have causal powers, whereas variability in the proton number does. So apart from possibly causing nuclear decay,
right? But there's various nuclear clusters have various decay rates. Various isotopes have various decay rates. This is like, that's the thing. It's like that's not really well represented in the chart, and I think that's actually quite informative.
I think so too, because the distance from a species to the most stable state predicts how reactive it is. So the farther away it is from the island or the whatever the most proximal stable state is, the more reactive it is. So that inverse determination to me negates the need to represent it in a graph the way there's a need to represent the quantum periodic table in a graph, but that's because the quantum periodic table turns into the hyperbolic complement of the figure 8 knot, which has causal powers with regards to organic matter.
Sure.
Oh no, we went from the physical, and I don't know. It seemed to become ontological.
Well, I mean, memes. That's exactly what we're doing. Is most of the time that's what people can't do in philosophy. We want to go from the physical to the ontological, but we can't. But now we can.
Right, but I mean, I don't know where this figure 8 knot comes from.
Memes, did you want to tell Kaylee a little bit about at least that's?
Well, I mean, I know. I need you to be able to extract it from physically demonstrable universe somehow, or have a very good rationale for its application above all other knots.
Does its particular deformations predict the shape of organic matter?
How so?
I'll just get a diagram that shows how it works, but I could. Thanks for putting.
Well, it needs to be shown in a very physical. No, I've seen this thing before, right? The 4 thing.
Do you agree, or?
But I don't know why the 4. I can't remember why the 4.
Well, the image at the top left represents the quantum periodic table.
It's basically that representation there. Consider the center hydrogen. That would be, I don't know, pretty stable. If you're going to build up from there, helium is, I don't know, is that the most stable? Though then again, if you only have one proton.
Oh, I see. Okay. Yeah. Wait, can we get a better tilt on that too? There's not a diagram where you've got like we got a more oblique-ish angle, so the top diamond is more like diamond.
I know what you're saying, and possibly not, but I do have other angles of it.
Okay, sorry.
I also have it in a Blender. I have it in a Blender file. I don't know if you yourself are a Blender file, haha. But I could send you that file if you wanted to see it in 3D, hypothetically.
Well, that's the thing, and really it needs to be so that you press a start button and it goes pop, 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 pop through the layers, right? Because this is the thing. The way that's organized is so that the electrons, this is sort of a splay of the electrons stacking in the nucleus, yes?
Hey,
look,
Raquel.
I just want to say one thing. I have a hard time visualizing
hydrogen
stuff.
In the middle.
So I'm not disagreeing with you. I'm sorry. I didn't quite understand what you said because I'm trying to set up, because you asked for a visualization and I actually have one now. So I'm going to share that real quick in case that's what you're asking. And if it's not, we can still talk about whatever it is that you're saying. But the point is that this is a 3-dimensional representation of the periodic table, and each sphere represents 2 elements. So the center sphere is the first s orbital, and that's green. And so all the green spheres are s orbitals: yellow, P, blue, D, purple, F.
Oh, so, crazy. Okay. So that's basically what I was describing.
Yay for coincidences.
No. Don't worry, Jen, it gets better. But wait, There's more.
Wait, can you pause with a green line sort of centered at all?
I don't think I can pause this, unfortunately, because it's a GIF.
Okay, no, that's cool. That's cool. That's awesome.
No, hold on.
Okay.
I have a way to do
Thank
this.
you.
We has the technology. Hold on, I'm gonna hack it. Oh, well, you got it right there. All right. Oh no! I was just taking a screenshot.
Oh, I can
It's
put it
okay.
back. It's easy. I figured out how to change which
Yeah,
one I was doing.
okay, I get it now. So, so like the big center one is the S, right? Like the first S, and then you bounce
That's right.
outward, back and forth.
You can think of it doing that, and in a sense, it does do that. But in another sense, it imminently exists of its own form, entirely as a single shape.
Is it a vertex thing? Maybe.
I'm not sure what
That's
a vertex is. I'm not sure what exactly vertex means.
I'm viewing it as like two pyramids kind of coming down.
Are those orbital sizes accurate?
It's not. It doesn't represent orbital sizes in itself. It's something that derives orbital sizes. So basically, there's a theoretical posit that the way you predict chemical reactions is you take all the valence electrons involved in a particular reaction, and then you determine all the ways that those electrons can be configured in sums of sets of the same cardinality as the minimum energy states, which are the noble gases, so 2, 8, 18, 32. In addition to this, not just will you have the electrons arrange themselves into a state that emulates some combination of these noble states, the combination will itself have its internal energy minimized, which means it'll consist of the lowest number of possible boundaries. So it's a it's not fully deterministic because it offers relative computational probabilities of formation of different elements, but it's basically as close to a deterministic theory of matter as you can get, because it shows a direct way to compute what the valence states of atoms, or which is something up until now we could only infer through experiment.
Right. Huh. And this matches quite well, like the.
I don't understand it either. Don't. I'm slowly picking away. You're just observation. I'm like, well, that was kind of more than I got to, because I'm also quite ADD, so I go in different directions. One thing, Callie, apparently depending on how you look at the complement of the figure eight knot, essentially we actually found two trefoils, or Dad found two trefoils in there. I don't understand it either, but he's very confident he found basically. I don't know. I'm just saying that because I'm like, Callie's been talking about that for a while, and I'll see if I can't get more into it, because we've started to do some animations. They're absolutely fantastic. I don't know if it's showing reality, but it's like when you start mapping like the gamma function and stuff, it's like it depends on the magnitude. The first thing, it's like, all right, we just see looks a little like a contour map. There's not really much there. And then you set it to like 2,000 frames at a much greater magnitude. It's like, I believe the quote may have been, and the means of destruction channel does not promote entheogen use unless prescribed by a proper physician and brought to you by a multi-billion-dollar pharmaceutical company. Because that's the way things are. But I believe the quote was, I think this requires LSD. I started to put up some of the trippy things. This is a lot trippier.
Just offhand, another reason I thought about granularity that's intrinsic is quantum state exclusion. Although you could argue that the array of the periodic table is in some way determined by quantum state exclusion.
Yeah. So it's like the modulus interaction between those two stable sort of noble gases, or the excess neutrons.
Theoretically, basically, every single thought that nature has tries to emulate the mind of God. So every single chemical array that happens is going to try to emulate the most stable, similar array.
Yeah. No, actually, I was talking to somebody on Twitter today. They were talking about Leibniz, and they were sort of like, oh, well, then Leibniz's God is very limited, sort of, or something. I can't remember. I think that was their choice of words. And I was like,
Yo, have you ever
wait.
actually
And I was
seen
like,
any of those proofs?
wait. When Leibniz said that would be the best, I think there was some quote about like Leibniz saying would be the best God. And I was like, I think the context is that God will be so incredibly perfectly elegant, because what else could it be to be eternal? I mean, it's that sort of like that simple, because anything else, basically perturbations come up and you will catastrophe yourself down to that minimal perfection. And we have this beautiful perfection around us.
Again, I am very biased on this. I mean, I don't really disagree with it. See, that's the thing. That's why I'm like, all right, I think we're all kind of talking about the same thing. As long as we're just kind of trending in the same direction, I think that's good enough. And then you just keep on seeing more and more. And it's like, well, that's a very interesting coincidence. And once you start seeing it again, it's like, I'm I'm not professionally trained in this. I can be very obsessive about things, and I have the benefit of modern technology, like exponentially, potentially more information than the Library of Alexandria. And the more and more I kind of go into this, I'm like, I think a lot of folks a long time ago may have actually figured a lot of this stuff out. And if not, the degree to which they may have been right in what they were conjecturing at the time, it's very beautiful. It's very beautiful. Call it maybe poetic justice. I don't know.
I don't think they came up with the same things because we would know about it. But I think they came up with things the same way that we can still like that I came up with the periodic table. So I think
I
that
yeah.
that method of knowing things, which is called revelation, has become very obscured in the modern day. So unfortunately, its influence has been lacking.
I'm curious about how much was actually lost in the Library of Alexandria. Because I tend to agree with that statement. But every
Well,
once
that's
in
the
a
thing.
while,
Nothing was lost upon the burning of a library because the knowledge that is eternal is oral. It doesn't have any. It doesn't really have anything to do with books. You can use that knowledge to write books with, but you can't get it from a book.
wait a second. Are you saying Reading Rainbow's been lying to me all these years? Take
I
a
think that
look.
reading can
It's in
play a
a
big
book.
role. Actually, I
Reading.
think
Oh,
reading can help. It can accelerate the progression of your abstract imagination, as well as your discernment. So it can inspire you to think about things and discern within those things that you never thought about before, as well as imagine things you never imagined before. So it does have its use. It just doesn't itself transmit knowledge because only a person can do that. Because only a person can check that you understood it right when they told you.
it's well, okay. No, these are conversations that I probably not that long ago probably would have been pushed back on more. But over the past 2 weeks, and oh my god, I totally missed the D&D game last Sunday. Oh,
Oh
I
my
feel bad.
god, that's got to be
No,
some sort of life-altering
no,
thing
it's
there.
well, a
When
game
was
of
the last
Pathfinder
time you missed
technically.
a D&D
It's
game,
no,
man?
because we've been off for a couple of weeks, and I moved, and then that Sunday, I guess we were off again, and then I thought that this past Sunday I had checked, but the days kind of started to blend into each. I am a terrible party member. That's why we can't have nice things, folks. But I feel like I've learned, or at least seen a lot of coincidences. And like my old man, God rest his soul, like he was an attorney. So it's like one of the things I learned from him. It's like you follow the evidence. It's like, okay, let me follow some evidence. And it's like Jen remembers at one point, it's like I'm reaching out to Dr. Weinstein. I'm like, can we do stuff and things with geometric unity? I was actually surprised. It's like, I am so surprised. I'm like, oh, it's something. It's something that I hear about. The guy's making some claims. Maybe look into it and stuff. And then, like a week later, after trolling some folks and everything, Nolan had added me with like Thad's Twitter handle. I had moused over. I opened up a thing. I'm listening. I'm like, oh, that's kind of cool. That's a lot of claims. But I'm like, okay, it's a dude on the internet. I'm another dude on the internet. And then a little bit 12 hours later, I'm like, Muon G2 results. I'm like, oh, cool. Oh, there be a Mars rover moment. I'm like, okay, I guess this is a big deal. What the heck does this mean? I tweet at that. A guy made a claim. I'm like, does this help your results? He's like, yes. I go back, check the website, check the video. I'm like, huh, how did he do that? And then he's explaining a method. I'm like, I'm looking into it a bit. I don't hear folks saying that it's wrong. It seems to you'd be utilizing coherent things. The first time he popped up the two-dimensional, like Donald tiling constant version of the periodic table, I'm like, I've seen that before. Jen has that in 3D form. I'm like, this is interesting. I get maybe just a coincidence. And then you're talking about trefoils and just like Jen beat into my head a number of things. Thank you. You really reinforce just energy density, and just like the different fluid process. I remember the first time I looked up like Bernoulli and stuff. I'm like, I could see that explaining a lot. And I'm like, again, I just seeing a lot of folks saying a lot of the same things, even within the Wolfram Project. Even when Jonathan's bringing it up, it's like, okay, I mean, we can argue about this stuff forever, or we could try something and see if it works. We could be wrong. And because I think that was the whole thing, like with the Wolfram Institute, like a place to do science, to like actually show science to the world, have folks contribute and stuff. And like, that's kind of one of the ideas between the whole monastery. Total shout out. But it's like place for people to come, share some ideas. Because a lot of times, like, unless it's unfortunate that sometimes cult of personality and just kind of starting the drama and everything, as much as I like drama, that seems to carry the day all too often. And if we're actually going to make the claim and say, why are we doing science? Well, we seek to be less wrong. We want a better humanity. You also got to deal with humanity. So the better and worse. Jen.
Then we got to like define what it means to be right. And I found that those conversations are often quite terrible. Because you end up in an ontological discussion about truth, which is hard to resolve. So I'm open to that conversation. I just think it's gonna be hard to frame. Also, screen shared the progression of the HF because I was kind of like, thanks for giving the description of Thad's research because I didn't discover this shape. I just discovered that it can be obtained by deforming the periodic table, the quantum periodic table. And so if you just start with that shape and you deform it within itself, you can obtain the shapes of life forms starting from a single cell. So the single cell, the opening in the shape is non-local across its surface. And then as there's a process of evolution, the openings are separated by increasing degree.
Yeah. I studied developmental biology, actually.
Oh.
Because I found it fascinating, like this whole thing, the going from one cell and then multiplying, and then all of a sudden there's this weird catastrophic sort of like involution point that happens, that's really like, to me, it's like one of those magic things. It's like watching a flower actually open or something, where you start to form like the gastration and then like the formal of the notochord and all this stuff. It's just amazing,
Yeah.
But I still like why the figure 8 knot is there.
Because it represents embodied fourness, just as the periodic table does.
Okay.
So it's special because our existence privileges 4 dimensions. And in some sense, these dimensions are metaphysical primitives, as measurements are things we define within these limitations.
Okay.
So and
I'm going to
ultimately,
need to delve deeper to really understand it, but let's just move on because I need to totally grok things, but I don't yet. So Let's keep moving.
This was not something that was looked for. It just kind of like the volume equivalent just came out in like Wolfram Alpha. It just kept appearing. So that was kind of what led down this path and everything. So that was kind of like the deep lore of it. So where does that leave us? We're trying to establish some ontology for what's going on.
I'm trying to grab a better diagram that illustrates the principle of fourness in the QMPT.
I may have.
It means is it obvious to you at least that the QMPT has embodied fourness?
Well, it's basically it's got the square base, so basically it's kind of got the pyramid thing going right there. So I mean, I could see that and continue.
Well, I've got
what I want to see is like each of them labeled.
Right, so they are labeled with the numbers, and there's like several degrees of 3 plus 1, but the overall maximum size of anything within it is 3 plus 1.
Right, yeah, it's a little matrix working down from the two corners inversely, right? That's crazy.
I want to say yes, but I have, again, I just have a bit of a hard time actually putting what you're saying, to a concept, which is a shortcoming on my end here. So you're probably right.
No, it's like a Pascal triangle thing. Look, it's got the green, and then there's a little L of the next color, and then the next bigger L of the next color, the next bigger L of the next color, and the whole thing is inverted and rotated on the other end.
Exactly. So the idea is that
this is why I did the show, so people could solve problems that I don't understand. Thank you.
The idea is that because there's intrinsic fourness, there's only 118 elements. So there isn't really a reason for fourness. Fourness is just something we observe as intrinsic. And then fourness gives the reason for things like, for example, the fact that the periodic table doesn't go on forever, because conceptually you could just keep stacking more squares on the wings, right?
Right, like, but it's sort of the same way that, like, if you get an electron on too far on the outer orbit, it can just fall off. You know, it's the same thing. It's like your nucleons getting so far out that they're rubbing against the electron orbitals themselves in a way, and they're going to get, like, they just don't hold anymore. They don't have the gravity actually to hold them on to themselves. This is decay, which is strange. It's,
when you say, do you mean charge, or are you talking about total sum forces?
No, but I mean, like, as you add nucleons, at a certain point, they can't hold together anymore. That's the whole thing. They become radioactive. They want to fall apart and become a more stable form. There is no larger stable form after a certain point. The same way that a neutron isn't even stable once you pull it out of a nucleus.
And my model says that this effect happens because there's this dimensional limit whereby if the density is too great, you will have spontaneous decay. Because it can't just keep getting denser and denser and denser. And that's why I like to use the thought experiment when I'm reasoning about physics with people. Is it possible for matter to be infinitely dense?
Oh, I see. Okay. So in this model, sort of what would happen is, as the mass gets so large, let's call it, if we can call a neutron a double cover, right? It's a proton, like the mass unit part of the proton surrounded by an electron, but then the electron gets shoved down back inside kind of, and you get that double cover of the neutron, which is why it doesn't emit photons. It's just like a little pearl. But if you have too much sitting on that, it's almost like you're falling through the event horizon, where a neutron hits an event horizon. Now it's a triple cover. And that's not something that wants to be, which is why in my model, that neutron actually gets shot out in the deep void where there's lots and lots of room for it. and decays into hydrogen, etc. But in your model of the nuclear decay, what happens is it gets so crushed that it explodes and you have spontaneous decay.
No, in this model, particles don't exist.
So, well, okay, then the fluid pressure in the middle of it?
The result of granularity in space-time that would come about as a result of interactions on this level of matter. So there wouldn't be a free neutron without something having caused it. And so there wouldn't be triple covering in the event of a neutron because space is caused in this model. So time is not a cause, space is not a cause. Space and time are caused. So it wouldn't look quite like that, unfortunately.
But you were saying as a neutron or as a nucleus gets too large, there becomes a spontaneous decay.
Not too large, too dense. And that doesn't have anything to do with particles. That's just an energetic density. The appearance of particles comes about from the 3+1 measurement limit. Because there's so much motion that the measurement limit's always being probed. So you're always needing to model things as though they had a granularity, e.g. atoms. It's just that my model doesn't reason on an atomic basis. Atomism is a dualism that comes in at a later stage of reasoning, so there wouldn't be any appeals to any type of atomic construct like a proton or electron or neutron at this stage, because it just represents a symmetry in the electronic configuration intrinsic to matter.
So it's basically energy density.
But they're numbered.
It's an aggregation of relative energy density. What were you saying, Kaylee? Sorry?
They're integers, though.
That's right.
Which is rather granular, is all.
Well, yeah, that was my original point, was that there is intrinsic granularity. It's just not clear how we take it and use it in a model.
Okay. Yeah. Okay. But the pressure gets then the fluid, then in the model, the density, the fluid pressure in this core gets so high that there's spontaneous.
No, it's non-local. It's a non-local identity. So this gives rise to space. This doesn't have space. It only has a numerical information structure. So it appears to have space, but that's just us projecting our spatiality onto it.
I'm talking about real
spatiality arises within this shape.
I'm talking about real atoms, though.
Right, but in my model, there aren't any real atoms. So if you want to think about my model, like, you can't use atoms.
What we conceptualize as atoms.
Wait, there's no atoms? So
granularity.
There's no granularity to a gold atom?
Space-time granularity and atoms isn't the same thing. So my model affirms the granularity of space-time, like I affirm that gold is not silver, for example, but it denies that this is caused by atomism.
She's not going as far as to make the claim that atoms are a thing. She's performing an ontology based upon the granularity and the density, and it almost sounds like a probabilistic or maybe information theory type thing of where things are going to go, what would be like the least energy state for this, and then depending on that you would have decay and stuff like that. That's what I think I'm hearing. So it's
right,
I think rather than go
see atoms.
That's good memes. You're on the right track there, memes.
Yeah. Well,
whether it's an ontological thing or not, I mean, that's like saying a mango isn't really just the mango or something like that.
Well,
I mean,
why would our idea about mangoes have any reflection on how a mango as such actually exists? I mean, we can't presuppose that. And this gives us a way to guarantee that we don't presuppose it.
And then I can eat it.
Yeah, exactly.
Because it's a separate thing that I can pull apart with a knife.
Did you say mango? You said mango, right?
Mango, a mango,
Yeah,
a
the
fruit.
mango has an existence that we are evolved to perceive. And therefore, the reality of it doesn't reflect what we perceive because evolution takes time and therefore is different from what was originally there.
But I can be presented with something that I've never, ever, ever experienced ever before and investigate it and learn it.
Can you?
Yes.
Well, what can you learn about it?
Everything, because once I was a baby and then I was presented with things that I had never encountered before, and I constructed my own self-ontology of my existence within the universe, which is a rather, must be a very agreed upon thing, because people I've never met agree on so much about it with me.
Yeah, but because someone agrees with you the mango tastes good doesn't speak to what the purpose of philosophy is, which is precisely this mind-independent ontology if it exists. And so getting our mind dependence mixed up in ontological judgments is problematic to philosophy, not to eating mangoes.
I was talking about what is exactly that tipping point for this, however you want to describe this decay of the atoms when they get too big, heavy, dense thing.
That's not how it works in my model because there's no atoms in my model.
I think it comes down to an observer's,
what do you call the thing that is like, okay, you've got some lead and then you like somehow like smash something into the lead to make it another stuff that's sitting there waiting to be hit by something.
Is there a method of quantification that observers like us can understand?
You can see it with a microscope.
That question is actually cracked to me.
Okay.
Because like when you're me, you get asked like shitloads of dog shit questions.
No, but it's like you can look at separate atoms using pointers and devices, and yeah, it's like, is it an atom? Is it a density of energy? It's like, well, it's a density of energy. That's what we call an atom. I call a mango a bunch of density of energy that looks reddish green and is sitting on my counter.
Putting the ontological identification of what may or may not be a particular quantized form of energy in a particular granulated state.
The way to look at it is that none of us has ever seen an atom. Now, atoms might exist, but whether they exist or not, in my worldview, if you haven't perceived something, you can't reason on it. You can't axiomatize it, which means that you're reasoning departing from it as your only supposition.
She's trying to say she's trying not to say what I'm hearing is Jen's trying to say nothing that's false, because atoms, it's like, well, yeah. If you really press, it's like atoms are a thing.
No, I get it. I just find all ontological arguments totally boring, frankly, because they don't tend to lead towards an actual like either like when you constructed that diagram thing, right? The thing with the 4x4 thing.
Human, yeah.
Yes.
How did that come about?
God told me after I prayed for it for a long time. Results not likely.
So okay, I don't know. Anyways,
I'm just saying, it's like some folks may say, well, that's a crazy thing. I'm like, wait a second. Then Professor Feynman,
no, because I mean, like, I was introduced to compactified time by this weird creature I met during an LSD trip. This is like 30 years ago, 35 years ago. I didn't realize what I was being shown at the time. And then all of a sudden it dawned on me a couple of years ago after I thought about compactified time. Oh my God, that's what he was trying to show me, or this, I call it he, because it was like, I don't know. It was just so weird. But
see, it's the sheer fact that all three of us human beings, or whatever particular granulated forms of energy in this marvelous thing or being that we call universe, just the sheer fact that we are here, I believe, speaks poetic justice, or at least I'll make that claim, right there. And again, language is imperfect. It's like to communicate a message using even just one language. What do we have? Like 6,000, 8,000 official words. We have
Oh
slangs,
my
we have
God.
dialects, we incorporate different things. What are some things that we can try to use to describe things? All right, well, we use maths, which math does seem to know pretty well. You have different forms of math. I prefer to think of it more as just logic, depending on how you form that logic, depending on how you apply it, what your vantage point is, the knowledge that you have, the knowledge that others have around you. And these are the things that get me excited because we each have our own unique life experience. We're all more similar than we are different, but we've each traveled different paths. I personally think most folks are good people, but just because you're a good person doesn't mean you don't know stupid ass. I mean, I'm a dude wearing a yellow level up shirt and sunglasses at night somewhere in between the Monkeys after I joined a monastery. I drove 2,300 miles out here. That sounds like a pretty crazy story to just any outside observer, but I personally think it's a beautiful thing. I've learned a bunch from the people on the panel, folks in the chat and everything, because if I'm going to believe some of the words that come out of my own mouth, it's like, all right, well, life is like a movie. Let's make it the best dang movie possible. I mean, that's the way I look at it. And if it happens to make us less wrong or could maybe, I don't know, try to elevate us to a better understanding of what's actually going on, I think that's a good thing. Rant over.
Beautiful.
So I'm looking at a P and X delta axis here.
I can go into this if we're burnt out on the discussion about non-atomism. I can move on, but I can also explain how my model predicts nuclear decay without appealing to atomism.
Okay, so instead that would be like that's an energy density chart.
Okay, not quite. So the first thing to think about is that matter pre-exists its observables, of which there are 5. Memes, you want to rattle them off?
Oh, time, space, charge, mass, temperature. Go planet.
So matter has what can be referenced as a simultaneous quintessence. And so in as much as observation of one of these, whatever you want to call them, fundamental things, co-arises with the other 4. And I cite the Heisenberg uncertainty principle as evidence of this because there has to be a correlation between dimensionality if there's a limitation on the 2 components of dimensionality, position and momentum. So that I admit's a pretty weak argument, but just very loosely, this diagram shows that, so the way to think about it is that quantum state exclusion is true, which means that a maximum density is true, which means that and since there's gravity that arises in matter, there's a tendency for the distance to go to 0. Are you still following me?
Yeah, of course.
So what happens there is that the fact that quantum state exclusion is true becomes enforced by matter itself. So density makes it so that quantum state exclusion is about to be false, and then matter just comes right back and ensures that it remains true. And so decay events are basically nature keeping maximum density true.
I think hexagon. I believe the answer is maximum density, and Rick is asking for what is quintessence.
Well, memes defined it. It's space, time, temperature, charge, and mass.
Oh,
so
yeah.
These are
sometimes
observational. They're primitive notion.
Yeah, the word quintessence also comes and is used as sort of like the lambda. It's sort of like the like a dark energy stand-in sometimes in people's talk. Like it's the it would be my neutron decay in voids without necessarily a mechanism the way I have for it, but like that idea is sometimes thrown about as quintessence. It's like where everything comes from, but nobody's got an explanation for where it came from.
In this model, we would have an explanation for quintessence because we start with the QMPT, which is quintessence. Excuse me, if that's not the right word. And then when we induce motion on the QMPT, that's another dimension. So all the set of all sets of possible intrinsic motion induced on the QMPT is then quintessence, which is the hyperbolic complement of figure 8 knot. But yeah, what this diagram shows is that there's a space between quantum states which goes to 0, and by the Heisenberg uncertainty principle, as the space between states goes to 0, the delta between states goes to 0, the delta between the momentum between the states goes to infinity, which is where you get the energy to displace the matter from itself into the fissile material. So you can see how you can jettison, the atomic model and still retain all of your basic explanations for standard observations. They're just within a signal processing context instead of an atomic context.
Yeah. That's interesting because that relates to the way I was describing photons as being sort of like as an atom gets to drop its shells and become more energy dense, the photon is sort of like the space that's thrown off. It's like a burp that the atom needs to make so that it contract itself, because otherwise it's taking up all this room that it doesn't really want to be taking up. So Jen, at that limit at the gamma energy, right, at that low point, the highest energy point, yes? Or is that am I reading it wrong? At the right hand, it's like the lower right hand part, right?
That would be the lowest energy.
Gamma decay?
Yeah. Because it's massless. So it represents the least energy. So that means that you don't need as much of a proximity to generate it, because to generate more energy, you need more proximity between the quantum states induced by the pressure, induced by the gravity. Note how we're not appealing to atoms at any point.
Yeah. So, but there should therefore be, if there's a limit, that arrow should not keep on pointing there, shouldn't it?
That's a good point. I'm actually not sure, and the truth is I'm still developing this theory, so I would love to have any input that is possible.
It makes perfect sense. It makes perfect sense. It's like, the density is too high. It's not actually enough mass to properly become an event horizon, which is sort of like the scaled up version of this event in a weird way almost. And the supernova is the fission thing, like the eruption of the material from the middle, because it doesn't have enough mass to properly become that next scaled up version of itself, sort of.
Well, it doesn't have enough density, which is connected to mass. It's important to remember that all the reasoning is done with respect to density, because density.
No, it's true. That's the most important thing. A neutron by itself is not dense enough to hold itself together. It needs to be in a context that gives it that added density so that it can maintain. And I know the neutron, as soon as it's integrated, it's not separate anymore. But like, if you know what I mean, like the neutron just as a single thing, a free neutron, does not have near the density to hold itself together. And it blows apart and turns into a little hydrogen atom.
Well, and it wouldn't have enough gravity to hold itself together. So its density would return to the lowest energy density, which is the more diffuse state, which corresponds to 2 states instead of 1. So a neutron and a proton.
See, this is why I say I'm just taking certain terminology and I'm like, okay, I think that's a broad enough thing, and I think that's why a lot of what Jen's trying to do here, and she's even acknowledging, she's like, well, I'm not sure, it's still under development. It's like, but if you're going to, that comes down to, it's like, are we going to say it's discrete? Are we going to say it's continuous? If we don't know, or if there's going to be argument there, that's like, okay, is it asymptotic? Because if it's not, it's great. I guess we're claiming it's asymptotic.
No. I don't think we have to talk about asymptotic, because I don't even think we can I think we struggle to conceptualize of stuff like discrete and continuous. Asymptotic, forget about it. That's even more complicated. I think we need to reframe it to just look at what the evidence tells us, because the QMPT says that granularity or discreteness is fundamental. But our experience says that continuity is fundamental. And metaphysical parsimony says that continuity is fundamental because there's less energy in maintaining a continuous state than a discrete state, because it takes energy to form discretization. So there's arguments on both sides.
Well, yeah, that's the thing. Yeah. But if we look at it, that there's a universal continuity that runs underneath everything. That if an event horizon is sort of like an exposed sphere of that singular continuity, similar to the way what we call an atom, that this super dense droplet of energy that has all these little, like this, that used to be a bunch of pieces, but it all fell together into one droplet sort of thing, that same thing. And then that's the event horizon is the scale up of that sort of thing. So it's like the neutron is the smallest, or the subneutron, whatever that smallest particle is, the Planck particle, the Higgs, people want to call it, the little tiny massness that sits at the core of even a proton, that causes the deformation that creates the charge of the proton and electron.
Right. There'd be a granularity, which means there'd be an irreducible component of both mass and charge. Yes. Again, that does not imply, I know it sounds like it implies atomism, and it's totally fine to work with an atomistic model. When you're doing chemistry, use the atomistic model. We're not talking about chemistry here. That's all. This is different. We're talking about ontology. So
okay. So I totally got you.
The incredibly subtle distinction is that granularity plus irreducibility does not equal atomism. And welcome Sonic to the show.
Hey guys, this is Brad Voorhees from the Sonic Gravity podcast, and that's a fact. But no, I've had you all on here before. I didn't realize it was really short notice. I know you got the family, you got all the stuff going on, you've got your experiments and everything. But how you doing, brother?
I'm really good, really good. Hey, thanks for the invite too. I'm just kind of soaking this in right now.
I've learned a lot tonight. It's just, and that's one of the reasons why I'm like, all right, a lot of times people, especially on like a Twitter or even on Facebook or stuff like that, people will say things. All I know is I'm sure the Almighty wished us human beings to communicate in 140 characters or less.
Yeah. Which is very difficult for someone like me.
That's why I do like the videos and stuff, man. But thank you for joining. Right now I think Jen we were talking about, like, are things discrete? Are they continuous? Because Jen was showing us this.
You can have a continuity, but within, the same way that I'm trying to find, you can do it with oil. It's hard to do with most fluids because you need specific qualities of surface tension and stuff. But where you make a bubble of a fluid within the fluid itself. So there's not really a discontinuity. There's like an apparent discontinuity, and I have a strong thing about this, that it's essentially, it's the tangential quality. When something is perpendicular to you, it presents a surface. It gives this illusion of a separateness. With a cell, it's the cell membrane. There's dual layer with the Marangoni current that passes in the middle. With a neutron, it's like the double cover of the neutron, and there's going to be a tiny little gap in there because that's like the first hydrogen gap before there's actually one, because when the neutron decays, into hydrogen. But this this quality of this, like this double layer, and because of the double layer, there's a passage. The passage of the material between a double layer is like a superfluid condition where things can just zoom there. It's just, it gives that quality to like conditions. It's like the surface layer when you have water and you have glass. Right along that glass, like at a tiny, tiny layer, there is no dirt. There is not an ion. There is water and glass for a little surface layer. And it's like nature likes to have this, like sort of like echoes and echoes, the same way that overtones are the scales and the electrons, which is overtones, and how we don't use music for teaching electron orbitals and the integration of mass, and you increase the mass by 1 unit, and all of a sudden your frequency goes up and your overtones. I mean, it's all like, come on. It all integrates so beautifully. We really need to get our shit together. This is why I love that diagram of yours, Jen. Because I really feel like these sort of like physical diagrams really give a visceral way of communicating these ideas to people that words are not near as good at, you know? So to be able to refine ideas to that, I think is like essential. And that's really what we should be striving for as a species, so that through just play and exploring what we know to be sort of like, I don't like to see sacred geometries, but at the same time, you know, these things, these shapes that are very important and are very universal in their application. So I just like once I grokked that, now it's like, okay, I get that, you know?
That was very beautiful, golly.
You know, you said
Yeah, and
something.
when I met you, I had the sense that you would be able to understand.
Yeah, I just needed to wrap my head around it the right way.
I just think because we've both spent so much time thinking about the universe, that when you just spend all that time, that the deeper insights are a lot easier to assimilate. So Daryl, for example, in the chat, I don't know how long Daryl and I have been talking, and I've tried to explain my stuff to him, but yeah, there's still not any progress past the what does that mean times 500 to precept routine. So it's always nice when somebody is actually listening and taking the concept in and acknowledging that, yeah, like these diagrams actually do something that language doesn't. So Daryl, do better.
I always thought Daryl was a little bit of a troll like myself, but that personal opinion there. But I think Brad, did you have a comment there, brother?
No, I'm a huge fan of something that you said, which was that neutrons decay into hydrogen. And the reason, I did a podcast episode not too long ago, and I came to the conclusion shortly after I kind of assembled what my theory of everything was. And I did an episode called +1 + 1 = 0. And in it, I had surmised that so you take like, okay, just pretend this is a proton, right? 3 quarks, right? Now, when 3 quarks, and I don't want to go like totally into this and make this like about me or anything, but so if you have 3 quarks, like that's a proton. Now, if 2 protons fuse like this, the only way for them to go together, if they've got if there's 3 connections there, the only way for them to fuse is to scissor like lovers, like this. See? They scissor. Now, what this is a tetrahedron, and it's uniform any way you slice it. Any way you swing it. Okay, super. That. Now, so this. No, it's fine. Like, yeah, I mean, it's like sort of.
It's got 3 axes. No, that's the thing. It's like got 3 axes. It's like, yeah. Keep going.
But there's only 1, 2, 3, 4 places that can bond, because those are the only bonds. Those are the only gluons that are exposed. So, assuming that what happens is that the bond that's, say, here and the bond that's here, if they quantumly tunnel past each other and they lock, then yeah, you have this sort of octahedral thing, but the thing is it's symmetrical. Any way you turn it, it's symmetry. So, and that's why I think it kicks off. I think it essentially loses its charge. It becomes totally symmetrical, and then it kicks off those two. Each former hydrogen atom kicks off its 2 electrons, and that's fusion. That's your fusion energy. So it's really, I think, 2 protons becomes a neutron. And so when you say, oh, the neutrons decay into protons, I think that's 100% true. And we also know that the surface of a neutron star is hydrogen, like the atmosphere. And it's also true that every star that supernovas that doesn't leave a black hole leaves a neutron core and leaves a neutron star. And so that's why I think, and I did this podcast episode like a year and a half ago, and it's called +1 + 1 = 0. And it's because I think that hydrogen fusion yields neutrons. And one of the things that I said in support of that was that, when we figure out fusion, we figure out fusion power, we'll know that I'm right if it yields as byproducts neutrons. And it turns out that the National Ignition Facility that is, published 6 or 8 months ago, like results that showed, yeah, they've accomplished inertial confinement fusion, but they can't control the byproducts. They think it's really high energy ions that are escaping their magnetic fields, but that's not true. It's neutrons. The neutrons, you can't contain a neutron in a magnetic field, and that's why they're trashing their reactors every time they do the experiments, and they can't control their byproducts, is because they're neutrons. They're not helium ions. And so
high density fusion.
Yeah. In inertial confinement, that fusion, they're losing their, once they achieve fusion, they're tearing up their reactors because they can't control the byproducts. They think they're high energy ions, but they're not. They're just neutrons. And so anyway, so when you're talking, I didn't catch everything that you said, but when you talked about neutrons decaying into hydrogen, I'm a huge fan. And so I was like, because you said that, like, even though I don't really kind of get everything else, exactly everything that you were saying, I have a lot of faith in what you did say, because there were some things that you said that I would say to myself, yes, I get that. Like, I see what you're saying there. And so anyway, so that's just my little piece. So I didn't quite catch everything you were throwing, but
no, it's very interesting you said it, because as soon as you busted those out and you started to play around with them there, I'm like, oh, I've seen Kale do things with her sticks and like the foam, different colored balls and stuff. I'm like, all right, she was stressing vertices and everything. Now, maybe it's not the exact same thing, but I'm seeing other things. And even in octahedra, technically, if you take 2 tetrahedra and then you open up the bottom and everything, you can fit them together and stuff. So I think could be wrong.
No, yeah,
you have to do a deformation there, because it ends up being 8 equilateral triangles there. But that was fascinating. And actually, to be tangentially accurate here, I have no idea if this means anything. This is literally something that I just happened across while listening to the American Anti-Grav Association thing. Their very last lecture that I caught live, a gentleman was talking about tangents and cosines and this, and he had a little equation there. And I have some angles that I happen to be fond of, and I think tangentially, I don't know if it's connected, but I just threw this in here. Again, probably nothing. Tangent squared times the magic angle, all divided by 2. Oh, isn't such pretty notation? 1. Okay. What happens when we don't divide by 2? We get 2. I'm like, all right, well, what if we change that around? Let's do the tetrahedral angle. I mean, it's twice the magnitude, but it's one of those things I guess we use in chemistry and all these other like high precision things for MRIs and stuff like that. Full disclosure, the magic angle is half that, so it's going to be exactly what you think. 4. And when we don't divide by 2, 8. And again, probably nothing. I just thought it was pretty, and it made me think of Jen's quantum periodic table, just because I'm like, all right, we hit 4, we can extend out there, and this is just I don't know. I just thought it was neat. That was all. And Callie, it's a tangent.
Yeah, the geometry.
Yeah, I think anything that's a contribution that's numerical without being quantized is useful. So I support anything numerical without that doesn't axiomatize quantization.
I mean, I don't know what it means.
Or rather,
just
sorry, it doesn't axiomatize atomism. Sorry, not quantization.
It's kind of shown from a magazine.
Quantization is fine.
I'm a hardcore continuitist or whatever. Hardcore continuitist. There is only one thing, and we are part of it. It's like one giant surface or something, or volume or whatever. There's only one thing. Continuity is like, all of these things, this granularity, as you say, it's like it's granularity, and we'll play along with the granularity because it works well for like building atoms, and like when you're doing chemistry, as you said, it's like sometimes it's just a handy thing, but don't let that mess with your head too deep, because then you think true separateness or some kind of like absolute distinction, sort of,
The map is not necessarily the territory there. At least
exactly.
That's
no. Sorry, that's not what she's saying.
Okay.
What you're saying is true, but you don't want to trivialize that because it's an important point. The point Haley's saying is that the combination of quantization, granularity, and irreducibility is not the same thing as atomism, in the sense that atomism implies a separation.
Yeah, a complete distinctness that I don't think anybody who looks at this universe for a while thinks is true, because just things like to shmush. They like to have their little unity, their sense of self, just like we like to have our sense of self in a community. But as a community, the community as a whole has an identity that itself, oh, well, if they plucked you out and put somebody else in who's kind of like you, it would be different. But at the same time, it can be absorbed by that larger unity. Yet all of that is part of a larger and larger and larger scales of unities.
Unum e pluribus. I think that's what it is.
Well, no, the scales would come out of the unity, because the 3 plus oneness is true on every scale, and it's true in different ways.
Yes. Yeah. But I mean, that's the thing. You don't
need the Russian dolls to make the hierarchy, or you don't need the Russian dolls to make the identity. The identity makes the Russian dolls.
Yeah. Expands outwards. Yes. The sense of self expands outwards, whereas the totality already exists infinitely outwards, I would say.
I mean, I've heard a lot from different folks here at different times. I tend to think that, at least on a first level approach, I think we all kind of agree on that. There, I don't know. I could be wrong. Brad, thoughts?
I'm trying to soak it in.
It's trying a lot.
I'm trying to soak it in. So if I'm interpreting continuitist correctly, I'm not sure that describes me. I think, bringing it back to the ontology, I think that the universe is the 2D holographic surface of a black hole. And I think that if you took the surface of the black hole and you peeled it off and hung it like a sheet, right? That's the state of the energy in the universe at any instant in time, right? And so at every Planck time, you could peel the surface off the black hole and essentially stack them, right? Like slices of cheese. And you could stack them from the beginning of time to the end of time. And so distance across the slices of cheese becomes time-like. And I think that at every instant in Planck time, right, the 2D holographic surface of the black hole can change. It changes. And So I think in that sense, I think there are discrete changes in time, and I think space-time blows out of black holes for a lot of reasons, and if you see like and that's why the universe is expanding, right? Because there's space-time blowing out of every black hole, and the further out you look, the more black holes between here and there, the faster space is moving. Seems to be, expanding. But I think it's the space-time that's blowing through the surface of the black hole that changes the hologram, and that's what we notice, the passage of time. And this is my theory, right? So it's probably not what everybody else thinks. It's certainly not consensus.
But what almost sounds like you're saying there might be something one might consider a membrane, a brain, or something like that.
Yeah,
like
well, you could think of the surface of space-time. You could think of the surface of space-time as you skip to each next one. The changes in the energy on that surface is what we see as the passage of time, things moving, all that kind of stuff, right? So I think it's plausible that the shift, and I think the shift has to go like essentially like space to space. Like you have like causality is the communication between adjacent sort of, neutrinos or whatever you think. Essentially, the spots on the hologram are the vertices of the hologram. I think they're neutrinos, but essentially, that communication has to go neighbor to neighbor, which I think defines the light is speed limit, the speed of light. So I think I'm not sure that I think if everything was just continuous and it was 3 + 1, right, then I think you could get faster than light, but I don't think I think that the communication has to go, causality requires this limit, and the limit is the passage of time, essentially. Yeah, honey.
Mom is not ready.
Okay. So I'll be there in a sec. This is Bella.
Hi,
Bella.
So I think that the shift between, I think essentially the change in the hologram, sort of as you pass through time, I think it appears continuous, but I wonder if it is. You know what I mean? Like, and when you saw like the change in
Are
the
you
momentum,
saying time appears continuous?
I think
Just to be sure.
I think what we notice as the passage of time is the change in the hologram. And so if at every tick, information was being communicated, from one voxel of, space to the next, I think that's the speed of light. Like the fastest something can go is each tick communicating to each next, I think that's what defines the speed of light. But I think though that there's I think there's a in between where nothing's there. Like it's everything moves, and then in the next, instance, the sort of the energy on the surface of the space-time has changed. And so, and I think that's what that chart showed, was that Planck's constant, right? Planck's constant is really, the uncertainty principle is the chaos between changes on the hologram. You see what I mean? Anything smaller than that. Does that make sense? I mean, I guess that's just the way I interpret it. I'm not sure if that only makes sense.
I think this where Jen, don't you think this is like where that ontological difference sort of between like apparent discreteness or like the local discreteness rather than universal thing comes in?
Yeah. I mean, I think if you get small enough, you can see. You get small enough, then you have like the stop motion, right? But yeah, no, and of course, sort of the bigger you go or the lower resolution your camera is, like our eyes, it's gonna look totally continuous. But that's just, I don't know, that's just my ontology. I'm kind of stuck with it, right? Because I've, that's the that's the sonic gravity sort of theory of everything, or part of it anyway, is that we're on the 2D holographic surface of the black hole and space-time's blowing out of it. And I think that's why things are the way they are. But what I think is consistent with what that chart was showing, with the change in momentum over the change in distance, there's a minimum that you can't go below, the Heisenberg uncertainty principle. And I think the minimum below that is sort of a theoretical time space distance that's essentially smaller than
what happens between the ticks of the clock.
Yeah,
I don't know.
I mean, that's I think.
I mean,
so,
it sounds like we're trending kind of towards the screen. Sorry to cut you off. I know
that's
you need to
right.
get to
I
dinner.
think that's right. I mean, what I think is totally consistent with what that chart says. But maybe it's just an ontological sort of interpretation.
There's one of the reasons I set the things out. I know people have all their kind of different ideas, just kind of the way they develop their ideas, their processes, their life experience, and everything. But what I'm hearing, I'm like, I think a lot of this lines up, and you know what? Hey, I'm open to changing my ideas. That's one reason I invited people here, so I could get clarification. I know I learned a lot tonight. There were things where I had seen before, like, I don't know what that means. And hearing Kale explain things and hearing Brad again, just kind of like put some things out there. And I'm always learning from Jen. So I'm like, hey, thank you all for joining us and everything. So, I mean, we're coming up onto an hour and a half of the show. So I think we're going to wind things down. Brad, do you want to let the folks know what you got going on? I know you got dinner and everything. You got family. So.
Oh, yeah. Well, Bella wants her new bed built, so I've got to.
Well, we can't keep Bella from getting her new bed and everything. Brad, why don't you let the good folks know where they can find you and what you got going on?
Oh, sure. Yeah. So I'm just I'm an amateur podcaster. I'm an engineer, and I think I've sorted out anti-gravity. I'm putting a proposal together for DARPA funding. The rigs that I built are I can get between 1% and 7% mass reduction, but I really need some DARPA funding to build this nano-layered alloy to really make it sing. Sonic Gravity is my podcast. Sonic, hyphen gravity.us. Yeah, and
you need a vapor deposition chamber.
You're talking about for fabrication to do a nano-layered alloy to that's a great idea. I mean, I think that could be viable. I'm not a material scientist, so I know what I need.
I have access to some of this stuff. I have a standing invitation to research aerogels and carbon nanotubes.
Really? Very cool. Well, maybe we should talk like at some point. And I'll tell you exactly how I think anti-gravity works and why I need a nano-layered alloy. Essentially, it's like a left-handed electron bug catcher, so I can fill my magnetic field with cyclotronic left-handed electrons, and then I shake them because those are connected to the Higgs field. I think the Higgs field vacuum expectation value is negative 246 electron volts, not positive 246 gig electron volts.
Jump in anytime, Jen, because I don't do math.
and so I think if you fill it full of left-handed electrons and you shake them, you oscillate them at the right frequency. I think you can, if you can put 246 gig electron volts into left-handed electrons, and if they're connected to the Higgs field and the Higgs field negative 246, I think you could drop it to the ground state, and then everything in that field would be massless, if I'm right. So anyway, yeah, I mean, I'd love to, to talk about it if anybody, if you want to. Feel it's cool.
Brad's channel is in the tossed in the chat. I'll add it to the doobly-doo if I don't remind me. But other than that, Brad, hey, thank you so much for jumping on to episode 2 of the Cosmic Council. And Bella, tell Daddy to go make. Oh, you can't hear. Make your daughter's bed. Thank you for joining, brother.
I'm sure. Hey, thanks a lot, and thanks for sharing space with me and everything. I wish I could have been here earlier and heard more of what you said, because I was definitely catching some of what you were throwing. It's really cool.
I am horrifically known for doing things at the last minute. Jen can attest to that.
And I'm not a physicist, and I'm an engineer, and so anytime I can talk to you physicists, and I mean, it's huge opportunity. I love to do it.
I'm gonna do it on the internet. I love talking about the stuff just as much as you. But thank you
Go
for
make a
joining,
bed.
brother.
Go make a bed.
Okay, we'll see you guys later.
All right, peace out, my man.
See you later.
Thanks for having me, and thanks for giving me a chance to talk. And nice to meet you, Sonic, and hopefully see you again. But I'll let you go and make that bed because it looks like
It's a big
someone's
deal.
not willing to wait any longer.
Yeah,
Don't want
Jen,
to keep a
did
lady
you have any
waiting.
thoughts on what
Yeah,
he was saying?
Well, my worldview doesn't have particles in space. So I try to set up proofs that that is impossible by my metaphysical principles. So I think a discussion would be a bit more of a disagreement, and I don't think this is probably the time for that. But I mean,
Well, I'm just saying, from an engineering approach, from a purely engineering, because we're talking about constructing like condensed matter objects here. You know?
Episode 3.
Really?
Episode 3. We can do
Yeah,
that.
Okay,
definitely
another time.
Yeah,
I-
and
I
I would
put a-
love to hear your disagreement too. Like seriously, like it doesn't hurt
Awesome.
my feelings. Like
Oh, good.
tell me why it doesn't work. You know what I mean? Like, yeah, let me know.
Steel sharpens steel.
Yeah,
Exactly.
we're all friends.
Oh,
We're
I'm
all
glad
friends
to
here.
hear it.
Sure.
Memes, I don't know if you mind sharing the link I put in the private chat. It's just a video that I recently uploaded. So I had this conversation within the last couple days there. Possibly yesterday, but time when you're thinking about the concepts that I do, it all gets a bit blurry at the end of the day, doesn't it?
This is why I do videos and add a whole bunch of links to them, just because I'm
Thank
literally
you.
sifting through now and putting them in formalized like Wolfram notebooks and everything. Like, oh my god, I know it's here somewhere. I did this like 6 months ago. All right, Jen's link is in there, and
So yeah, please go
we
to my
have.
channel, and I'm looking forward to the next one. And as usual, the combo has been amazing. Thank
Yeah,
you,
thank you,
everyone.
Jen, for like helping me grok the thing.
Thank you so much for being open to it. I can tell you had a moment of insight today, at least.
Yeah.
Hey.
No, I just needed to grasp it. I knew there was something hiding in there. I just needed to understand what it was telling me.
All right, and Kali, final words here. Kali's link is in the chat and the doobly-doo as well. Where's he at for the folks?
Walk gentle. Walk gentle.
Yeah, go to my bed now.
All right. And that, all right, the fine panelists, their links are in the chat.
Sure.
I will update Brad's on the doobly-doo. Thank you all for joining. Peace out, everybody. Take care of yourselves because I'm going to make it the claim the best is yet to come. And that's a fact.
A fact.
I hope. I think. Peace out, everybody.